So let's take a look at number 17 in section 3.8, where to find the derivative of this function. This y is a function of x. Okay, so in this, you have a product of two functions, 4x to the 7th times notice this is the tangent inverse function. Okay, most of you are on ball, have watched the lecture videos and know what's going on. If some of you, I can tell, were not, because you treated this -1 here as an exponent. This is not tangent of 5x to the -1 power. By the way, that would be cotangent of 5x. Okay, so this is the arctangent or tangent inverse function. Now, the derivative for the inverse tangent function or arctangent function is this. We derived that in the lecture video, so you should watch that and know how to derive that and understand that. But in application, if we have the derivative with respect to x of tangent inverse of u, therefore, by the chain rule, derivative of the outer function, right, evaluated at the inner, times the derivative of the inner function, which we can write a little shorter this way. Okay, so that's the derivative of the arctangent function that will be involved in here. First off, before we do that, though, we have two functions that are multiplied. So again, we have to use what rule? We have to use the product rule. Okay, so I take the derivative of the first function times the second plus the first function times the derivative of the second. Derivative of the first is pretty easy, right? By the power rule, the 7 comes down. 7 times 4 is 28. Subtract 1 from 7 gives me x to the 6. So that's just straight up power rule. This, though, of course, we're going to have to use this chain rule here, where the outer function is the arctangent function. So the derivative of the outer function is 1 divided by u squared plus 1, where what's u? U is the inner function 5x. So it's quantity 5x squared plus 1 times the derivative of the inner function, which is 5x. With respect to x, that derivative is just 5. So I have 5 times 1 is 5. 5x squared, be careful, 5 squared is 25x squared. Okay, please know the difference between 5x squared and 5x squared. These are not the same expression. All right, the top one is 25x squared, whereas, of course, the bottom is just 5x squared. These are not the same. Okay, so what's the final derivative then? It's 28x to the 6th times tangent inverse of 5x plus this expression here, right? The derivative of this is this part right here in green times the 4x to the 7th. Well, 5 times 4x to the 7th is 20x to the 7th. 4 times 5 being 20, all over 25x squared plus 1. And that's a sufficient form to put the final result in. You don't have to combine these as one fraction by finding a common denominator. You certainly can. And sometimes there are times when you want to simplify things like that. But right now, this is sufficient. A lot of these functions that we're working with in these last sections, 3.8 and 3.9, well, especially 3.9, they get kind of weird. They're just weird functions, and you're just showing that you understand the various rules, product rules, quotient rules, and certainly chain rule, and of course the new rules that we're learning for the inverse trig functions or the exponential or logarithmic function. Okay, hope this helps on this one. If you have questions, let me know.